Okay, so as you know, we have talked about the fact that this next problem is going to use integration by parts twice, but we're not going to want to use the table, and that was because the table would have the u and its derivative column would just go on infinitely, and so we would never actually be able to write down our answer. So we have to try something else. So let's go ahead and just sort of trust the process, and they told me to do integration by parts. Let's do it. If I'm following my LIATE acronym, then I see that I have an exponential expression and I have a trig expression. Since trig comes before exponential, I'm going to choose my u to be my trig expression and my v prime to be my exponential. So the derivative of sine is cosine, of course, and the antiderivative of e to the x is e to the x. Okay, so integration by parts says that this integral, e to the x sine x dx, is equal to u times v minus the integral of u prime v. And so we look again and we see that it doesn't really look like we've gotten ourselves any closer. And that's okay because we're supposed to do parts twice. So let's just again follow the process. Again, I have an exponential and a trig expression, so I choose the trig for my u. And so the derivative of cosine is negative sine, and the antiderivative of e to the x is e to the x. Okay, so I remember to carry down what I already had, the e to the x sine x minus, open parentheses, now I'm doing parts on just the second integral, right? So all of this that follows the subtraction sign is this whole integral. So we have our new u times v minus the integral of u prime v. So that's a negative e to the x sine x. Okay, so I'm going to just clean this up a little bit by distributing my negative. So this becomes a negative e to the x cosine x, and this negative become positive, but actually I have another negative there, so it's like 3 negatives. Give me still left 1 negative. Okay, and so if I write this whole equality, I've done my integration by parts twice. And as it says in part B, once we've done this, we're supposed to notice a relationship between our original integral and our result. Sorry if you guys hear my daughter running around there. Okay, so let's look at something. We notice that in my results, I have what I started with. So at first glance, you might think we just went in a big circle. But actually what's happening is something similar to, like, just think about algebraically. If algebraically we had something like y equals something like, I don't know, 5 minus another y, right? So I'm trying to simplify this and sort of think about this is acting like some variable y. Then I've got equals some stuff, which I'm going to just simplify and just pretend it's a number, just to give you an idea algebraically what we're sort of comparing to. So I'm oversimplifying this just to give you an algebraic idea, right? So in Algebra 1, if someone said solve for y, what would you do? Well, you would try to get all of your y's to one side of the equation. So you would add this y over to the other side, and these would cancel because you get a 0y here. On the left we'd have 2y, and on the right we'd have 5. So to solve for y, we would divide both sides by 2, and we get our answer that y equals 5 halves. Well, as much as this equation is a more complicated equation, it's not any harder in terms of algebra how to solve for it. So the way, let's turn this back to red. The way we solve this is, I'm going to rewrite it. We have our integral e to the x sine x dx equals e to the x sine x minus e to the x cosine x minus that original integral, right? So I'm just rewriting what we just had. And so I want to try to get these two things together. So I'm going to add this integral. Oh, my daughter's not happy I'm videoing right now. I'm going to add the integral of e to the x sine x to both sides. They are like terms, right? So when I add them, this gives me 0 of them, so they cancel. And so on the right side of the equation, I just have my e to the x sine x minus e to the x cosine x. And on the left side, I've got one integral plus another one integral. So I've got 2 of them. So this is a lot like the simplified version we did with y. And so to solve for this integral, which of course is what we were supposed to find, right? We're supposed to actually find this integral. We just divide both sides by 2. And then we have to also remember to add our plus c at the end. So this is our final result because these 2's cancel. Right, so to summarize, in this instance we did integration parts until we recovered our original integral. So some people call this sort of the recovery way of using integration by parts. So just to remind you, on the board, I had talked to you at one point about how there's 4 ways to use parts. There's the sort of traditional product. There's when you're integrating a single term, and you let u be what you're given, and the v prime equals 1. The third one was the table, which was repeated integration by parts. And this fourth one, now finally, is our recovery method. So we've now seen all 4 ways of doing integration by parts. Let's see if we can do another example. Okay, so this one is going to get a little bit messier just because we have some coefficients, but you know, the process is going to be the same. So let's go ahead and notice that again we have an exponential and a trig, so this is going to be the classic sort of setup for this kind of problem. And so I'm going to choose my u to be, because on the LIATE, the t comes first. So my u is cosine of 2x, and my v prime will be e to the 3x. So the derivative of cosine is, well, of the 2x is going to be a negative sine of 2x, and then by chain rule times 2. I know I say this frequently in class, and I do mean it, that you have to make sure you're careful about when you're taking derivatives and when you're taking antiderivatives. Here, because we're taking the derivative, we are multiplying by the 2. Versus over here, when we take the antiderivative, it's going to be e to the 3x divided by 3 or times 1/3. So here we are undoing chain rule by dividing by that 3. Okay, so integration by parts says that this integral is going to be u times v. So 1/3 e to the 3x cosine of 2x minus the integral of u prime v. So that's going to be a negative 2/3 e to the 3x sine of 2x. Okay, so that's the same thing. I like to, when I can, pull out my coefficients. So I'm going to pull out this negative 2/3, so it's going to become a positive 2/3 times the integral of e to the 3x sine of 2x. Okay, so we have to do parts again, right? We have an e to the 3x times a sine now, and we want to do it again until we recover back to the original integral. So I choose my u to be sine of 2x, and my v prime to be e to the 3x. Derivative of sine of 2x is going to be 2 times cosine of 2x. And then v we already know. So we have, I'm carrying down this stuff, right? Carrying this down, 1/3 e to the 3x cosine of 2x plus 2/3, and then remember that parentheses to keep track of what's happening. Whatever follows this 2/3 here is representing this whole integral. So we're doing parts again on this integral. So we have another u times v minus the integral of u prime v. So the 2 and the 3rd is 2/3 e to the 3x. Ooh, I'm just barely going to fit this dx. Okay, sorry about that. Okay, so this whole thing is equal to our original integral e to the 3x cosine of 2x dx. Okay, and I have to be mindful of the fact that even though I squished, this has a parenthesis, so I have to remember that there's like a parenthesis over here too. Okay, so I'm going to move everything over a little bit. So we have our integral of e to the 3x cosine of 2x dx is equal to 1/3 e to the 3x cosine of 2x plus this 2/3 gets distributed. Sorry, I'm using a tablet here, so that's why I'm not writing directly on here. So sorry for my handwriting here. All right, so we have the 2/9 e to the 3x sine of 2x minus, so I have the 2/3 plus I have this 2/3 is also coming out, right? So I've got 4/9 times the integral of e to the 3x cosine of 2x dx. Okay, so we've got this integral is we've recovered the original one, right? See, this looks exactly like our other. We have the integral of e to the 3x cosine of 2x, integral of e to the 3x cosine of 2x. Same thing. So they are like terms, so I'm going to add the 4/9 e to the 3x cosine 2x to both sides. And when I add on the right side, these cancel, right? Because I get 0 of them. So let's see how well I can draw a straight line. Okay, and I need to scroll down a little bit. Okay, so what happens when I have one integral plus 4/9 of the integral? Well, this is like 9/9 plus 4/9, so that means I have 13/9 times the integral. And all of that is equal now to the rest of this stuff. 1/3 e to the 3x cosine of 2x plus 2/9 e to the 3x sine of 2x. So if I want to solve for this integral, I could divide by 13/9, or better yet, what I'm really going to do is just multiply everything by 9/13, right, the reciprocal. So that will cancel over here, and I'll have the integral of e to the 3x cosine of 2x dx equals, and so when I multiply the, maybe I should write the 9/13 here. When I multiply the 9/13 to this side, so the 9 and the 3, so that's going to reduce to 3/13. Make sure you're following all of my algebra here, and if you're not, then rewind. When I multiply by the 2/9, the 9 and the 9 cancel, so I'm going to be left with 2/13 e to the 3x sine of 2x. And then we just have to remember our plus c at the end. And there we go. That is our result. Okay, I think this video is getting long enough.